Did you know the fruity smell in perfumes, flavors, and even in medicines comes from a simple reaction known as esterification? Today, let's uncover this simple reaction step by step and see why it is so important in pharmaceutical chemistry. Hi, I am Dr. Swathi, your organic chemistry coach. In this video, we will break down the esterification reaction from definition to its pharmaceutical applications, plus a quick look into its qualitative tests. Subscribe my channel right now and stay with me till the end of the video. Now let's jump into the topic. So esterification is one of the most important chemical reaction which usually occurs between a carboxylic acid and an alcohol in the presence of an acid catalyst. Here, sulfuric acid is used as acid catalyst. Carboxylic acid reacts with alcohol. So you can see here the hydroxyl group from carboxylic acid and the hydrogen from alcohol will be removed in the form of water. So that is why we get water as one of the byproduct in this reaction. Now this R1O group will be transferred onto the carbonyl group of the carboxylic acid. So that is how there will be formation of an ester. Let's consider an example for this. An example carboxylic acid is acetic acid. When it reacts with ethyl alcohol in the presence of sulfuric acid, it gives ethyl acetate as the product with the elimination of water molecule. So here also what is happening? The hydroxyl group from acetic acid and hydrogen from ethyl alcohol is removed. Just this ethoxy group, C2H5O group, is attached to the carbonyl group of the acid. This is how we get ethyl acetate as the product. Now let me explain briefly the pharmaceutical importance of esterification reaction. So these esters are widely used in pharmacy for the preparation of flavors. So ethyl acetate, isoamyl acetate, these are some of the examples for esters which are used as flavoring agents in the pharmaceutical industry. So this isoamyl acetate is also known as banana oil because of its flavor. And these esters are also used in manufacturing of perfumes and fragrances. These are also used in drug formulations. Drugs such as aspirin are prepared by esterification reaction because this aspirin is an ester of salicylic acid. So you can see the reaction here. This is the structure of salicylic acid. So this salicylic acid is having carboxylic group and OH group ortho to each other. So when we treat this compound with acetic acid in the presence of concentrated sulfuric acid, now this OH group will be undergoing acetylation. Hydrogen from salicylic acid and hydroxyl group from acetic acid are removed in the form of water, and this acetyl group is attached to the oxygen of the salicylic acid. So that is how we get acetylated salicylic acid, which is nothing but aspirin, which is known for its anti-inflammatory activity. Some of the drugs are converted into prodrugs by esterification reaction because the resulting esters will be improving solubility and also the absorption properties of the drugs. Because as a result of esterification, carbonyl group will be introduced into the drug molecule, which is having polar properties, due to which the solubility will be enhanced. In addition to that, as a result of esterification reaction, carbon chain will be increased in the drug. So increased number of carbons will be responsible for the high lipophilicity and which plays a major role in the absorption of drugs. Now, let me briefly explain the mechanism involved in esterification reaction. So, the mechanism involves 5 steps. First step is protonation of carboxylic acid. And then nucleophile will be attacking on the protonated carboxylic acid. Then proton transfer occurs. Then there will be elimination of water molecule, which is also known as dehydration. And finally, upon deprotonation, we get corresponding ester. Now, let me discuss this step-by-step mechanism. First step in esterification is protonation. So the sulfuric acid generates protons, and due to the electronegativity of carbonyl oxygen, so this oxygen will be taking up the protons. So that is how protonation of carboxylic acid occurs in the first step. The electronegative oxygen, while making bond with hydrogen, it will utilize one of its pi bond electrons. So that is how we get corresponding protonated carboxylic acid. Now in this, because the carbonyl oxygen is losing its electron pair, which is previously given to the proton, here the carbonyl carbon becomes electron deficient. So that is how it is attaining the positive charge. Now in the second step, nucleophile attacks. So here the alcohol molecule will be acting as nucleophile, particularly the OR minus group which is present in alcohol because oxygen has two lone pairs of electrons and it is electronegative in nature. Further, the alkyl group, that is R prime group present in alcohol, is an electron donating group. So it donates electrons towards oxygen. That is how the electron density on the oxygen of alcohol is increased. So that is how it acts as nucleophile, and this nucleophile will be attacking on the electrophilic carbon. That means carbon which is holding the positive charge in the protonated acid. So that is how nucleophilic attack occurs in the second step. So thus results in the formation of intermediate where the oxygen bears positive charge because the oxygen, by utilizing one of its lone pair of electrons, it is making a bond with the electropositive carbon of the carboxylic acid. As it is losing electron pair, oxygen attains positive charge. Now, to remove the positive charge from the oxygen, the molecule has to undergo deprotonation. That means hydrogen leaves the molecule without the bonded pair of electrons, and this bonded pair of electrons will be supplied to oxygen to remove the positive charge. And these protons will be taken up by one of the OH group of the carboxylic acid. So that is how third step involves is proton transfer. That means within the same molecule, proton will be transferred from alcoholic oxygen to the carboxylic oxygen. So now, because carboxylic oxygen is having, again, wherever oxygen is there, two lone pairs of electrons will be there. So by using one of the lone pair, a carboxylic oxygen will be making bond with the hydrogen. That is how a positive charge will be generated on the oxygen because it is losing one of its naturally available electron pair. Now, once we get such type of molecule, the immediate step will be dehydration because here you can see molecular structure which is resembling as that of water molecule is ready. So immediately this carbon oxygen bond will be dissociated and the bonded electron pair will be migrated onto oxygen to remove the positive charge from the oxygen. Because this bonded pair of electrons is supplied to oxygen, this carbonyl carbon, carboxylic acid carbon becomes electron deficient. That is the reason it attains positive charge. Okay. Now to remove the positive charge from this particular molecule, immediately neighboring OH group is there. So the OH hydrogens will be undergoing deprotonation. So upon deprotonation in the fifth step, the hydrogens will be removed and whatever the bond is there between oxygen and hydrogen, that will be supplied to carbon so that the positive charge from the carbon will be removed. So that is why COH bond becomes C double bond O in the product. So that is how finally we get ester. So this is how by protonation followed by nucleophilic attack and proton transfer, elimination of water, and then finally deprotonation, acid and alcohols will be converted to ester. So this esterification test is one of the important qualitative tests which is used to determine the presence of alcohols as well as acids. Because as we know, esters are formed by the reaction between carboxylic acid and alcohol. That means if any compound, unknown compound is forming ester means either the given sample might be a carboxylic acid or it might be an alcohol. Okay. Now let us consider these two conditions separately. The first one is, let us say if the given sample is carboxylic acid, then we will take one part of the sample solution, add ethanol and concentrated sulfuric acid to it. Shake it well and immediately heat it for few seconds. So as soon as you heat it, if the given sample is carboxylic acid, then it reacts with alcohol in the presence of acid and it generates esters. So how we can say whether esters are formed or not? If the given compound is carboxylic acid, immediately we will get fruity odor due to the formation of ester. So that is how we can confirm the presence of carboxylic acid in the given sample. Now, the other condition, the same esterification test can be used even as one of the identification tests for the alcohols. So, if we suspect that given compound is alcohol, then take one part of the sample solution and add acetic acid because we are suspecting that it is alcohol. Now, to convert it into an ester form, we have to add carboxylic acid. So, add one part of glacial acetic acid and one part of concentrated sulfuric acid to it, shake it well and immediately heat it for few seconds. Then if the given compound is alcohol, it reacts with carboxylic acid in the presence of acid and immediately it generates ester. Again, it is confirmed by the formation of, by observing fruity odor. And that is how we can confirm the alcohols. So this is how esterification is one of the common tests by which we can identify the presence of both carboxylic and hydroxyl functionalities in the given compound. So esterification is not just a classroom reaction, it's a fundamental tool in making esters that impact perfumes, flavors, and pharmaceutical products. If this video helped you to understand esterification reaction, then give it a thumb and share it with your friends, and don't forget to subscribe my video for more chemistry concepts and study tips. For deeper understanding, check out my detailed video on qualitative tests for alcohols. The link is given in the description. Thanks for watching.